Hello Hornets, welcome and thank you for joining me today. Today we're going to be taking a look at the derivative of the absolute value of x. Now one of the things that we have here, and I want you to look at, is we already know that the tangent lines overlap lines, thus giving them the same slope. Absolute value functions have opposite slopes of that shown to the left, which means that they actually have two slopes, a slope to the right and a slope to the left. Thus, when we look at this, you notice we have that jump discontinuity in this type of a problem. And we've seen these before, where the limit from the left is a -1 and the limit from the right is a +1. Now, if we take a look and we ask ourselves about absolute values, the discontinuity or the non-differentiable point is that vertex point at the bottom. But what we end up with is a slope on this side that is a positive number, and the slope on this side which is the opposite of that same number. So if I call that slope an A, I'm looking at an A and a negative A. Now as a result, when we look at that d dx of the absolute value of x, you'll notice that we're looking at two distinctly different slopes, okay? And the derivative turns out to be the absolute value of x over x, and this gives us the two possible slopes of a positive or -1. And if I have a coefficient of a out in front, now I see it clearly. It's now the plus or minus of a. And you'll recall that we saw that when we were working with our limits. Remember how we had the limit as x approaches a from the left for the absolute value of x minus a over x minus a? And we saw that this gave us a slope of -1. And when we did the limit as x approaches a from the right for the absolute value x minus a over x minus a, we're looking at a +1. So if I'm trying to find the derivative, let's say find the derivative d dx of the absolute value, and let's just say 3x. Once again, we're looking at something that's fairly straightforward. We would move the constant out in front and then take the derivative d dx of x. And this gives me a positive and a negative slope of 3. And if you think about this function, the graph looks like this, sitting at 0, 0. And to the right, we have a +3 slope, and to the left, we have a -3 slope, thus giving us the possibilities. Okay? So just be aware that absolute values are often weird, and it's often, in fact, I would even go so far as to say that I would graph my absolute value and I would look at my derivative. So if I were asked to find d dx of the absolute value of 3x plus 2, I'm now looking at it and saying, well, this graph has, let's factor out the 3, leaving us with x plus 2/3 plus 0 equals y. And I would now graph this, opens up, it has the point, -2/3, 0, and this side is a +3, and this side is the -3. And as a result, I can now find my two derivatives, the derivative on the left and the derivative on the right, depending upon what is asked. Okay? So once again, notice that absolute values have two different possibilities, depending upon which line we are on. Now, we could always find the equation of this line by simply letting this be a -3 and distributing it to x plus 2/3, and it's going to give us our first equation to the left. And you'll notice I end up getting -3x minus 2. And this is now y equals -3x minus 2. it still has a derivative of negative 3. In order to find the other one, I use the positive x, and this ends up giving me 3x plus 2, which now has to be this line right here, 3x plus 2. Okay? So just be aware that we worked with our absolute values last year, and last year we saw that absolute values have two equations, one on the left, one on the right of the axis of symmetry, and as a result we can find the two and then look at the slopes, or we can just follow our rule and find our slopes this way. So this has been working with the absolute value, the derivative of an absolute value, where an absolute value has two slopes, one on the left and one on the right, and the way in which we get them. I hope this has helped. Please make sure, if you like this, please make sure you click like in the YouTube, and hopefully this is a positive video. Thank you very much. Be well and take care. Bye-bye.